Hello, everyone. Welcome to our Ask a Champion event. So I'd firstly like to thank our FTC champions, Rev Amped Robotics, GatorBytes, Java the Huts, Technical Difficulties, Curiosity, Tech Tigers, and Atlas Tech Titans for joining us and helping us with these event. I'm not sure if all the teams are here, but I can see a few of them already. So thanks for joining us. So all the teams will have a short 3 to 5 minute presentation introducing themselves and their successful championship season. So we're going to get to ask them questions after all of the teams present. So make sure you take note of your questions if you have any. And before we start the event, I would like to quickly introduce ourselves and why we hosted this event.
Also, not fair warning, but just as a thing to note, this meeting is being recorded and being sent to social media like YouTube and things like that. Just as a reminder. So if you want to rewatch this, you can go find it on YouTube.
Yep. So I'm going to briefly introduce ourselves before we start. All right, Ask a Champion. So who are we? We are a third-year FTC team from Walnut, California. We are a 6-member community team. We have 4 9th graders and 2 8th graders on our team, and we won the Design Award and our first year and Innovate Award last year. So why did we host this event? We wanted to learn how teams became a champion, so we invited 7 FTC champions with us today. We decided it'd be awesome to invite other FTC teams like you guys to come join us and learn along with us about being a champion. And these champions have generously agreed to help us with this event and share about their championship season. So we would like to thank these teams for co-hosting and making this event possible. And without further ado, we should start learning from these champions. So the order of the presentation is randomized. So the order is RevAmped Robotics, GatorBytes, Java the Huts, Technical Difficulties, Curiosity, Tech Tigers, and Atlas Tech Titans. I'm gonna send the order in the chat so you guys can like plan ahead or yep. All right, I sent the order. So Revamped Robotics, whenever you guys are ready.
Yeah. All right. Let me screen share real quick.
All right.
Can you guys see?
Yep.
All right. Sounds good. All right.
Yeah.
Hello. We're team 1288 Revamp Robotics, and my name is Joanna, and I'm the captain.
Yeah, my name is Jaden. I do mechanical design, outreaching, and stuff like that. Yeah. So about us. So during Fight Frenzy season, we were part of the Jemison Alliance. We were one of the finalists, I believe. And in 2024, we won the Engineering Portfolio Awards.
And a couple other awards and qualifications to Worlds in the previous years. So a little bit about us is this is our main build process that we like to use. So it includes brainstorming, prototyping, fabricating, and testing. And these 4 components are essential for our design process. So in the brainstorming phase, we like to create our criteria for each mechanism and lay our initial thoughts on whiteboard drawings. Here, we actually really encourage our team members to think about their own designs and then actually prototype them themselves by using a mixture of CAD and then implementing the CAD into 3D printed parts, where we're able to easily change these components and continue iterating upon them. So the first case study is our deposition system from Fight Frenzy. And it was a simple intake cup that was raised on a set of linear slides that incorporated a door mechanism. And this door mechanism prevented multiple freights from entering by incorporating the usage of a color sensor. And this really helped us automate our process to make it easier on our drivers. The next case study we'll look into is our team shipping element from that year. So originally we designed a really bulky 3D printed part that was super tall but skinny, and we thought that was the most efficient. But later we realized that by adding magnets on the top of our team shipping elements, it allowed 2 points of contact with our magnetic bar, but also was super easy to put on the top and quickly remove the component from our robot. And this included a free dangling pickup plate that maintained vertical orientation throughout the entire process.
Yeah, so the most important part outside of the robot for us is the outreaching. So we have two main types, community outreaches and technical outreaches. So for community outreaches, we love helping our community, helping other teams, and more things like that. So that year we mentored the team High Voltage, and we also helped the Beaverton Cultural Inclusion Program by teaching people about STEM. Along with that, we became first ambassadors, and we had a post kickoff live Q&A hosted by us, and we had a remote robot as you see down there, and we also helped some healthcare. All right, so on the other side of outreaches, we have industrial outreaches and international outreaches. So we met up with Mastercam, a company that makes a cam software used by professional designers. And we also met in the Northwest Machine Expo, where there were many companies that showed their interesting technologies, and we learned a lot and expanded our connections. Then we have some international outreaches that year, which was in the Minnesota Tech Conference. We learned about tech from professionals, and we also hosted the World Shop International Robotics Competition with other FTC teams around the world to learn about robotics and FTC.
So some key points that allowed us to be successful that year was that our robot went through many, many different refined iterations. And through the implementation of our design cycle, which we continuously follow throughout the year, that allowed us to maximize and fully capitalize on our design. And lastly, the outreaches that we did also really helped us be successful that year too. So we were truly ambassadors of FIRST, and we aimed to spread FIRST all around the world. We helped over 20 different JFLL, FLL, and FTC teams, and also connected with 2,500 different people in 10 different countries. Thank you for listening.
Thank you, Rev Damped Robotics, for your presentation. And remember, if you guys have any questions, make sure to keep note of them because you can ask your questions after all the teams are done presenting. So the next team to present is GatorBytes. Joseph, whenever you're ready.
Is my audio good?
Yep, we can hear you.
Okay. All right. Okay, so a little bit about me. My name is Joseph. I was the team founder and captain for 18457 GatorBytes out of Southern California. I did 4 years of First Lego League, and then I took a year off, and I did 3 years of First Tech Challenge. And we were the 2023 Winning Alliance captain from the Power Play season at the Houston World Championships. So some of our goals for Power Play, you always got to set goals whenever you are starting your season. Some teams they want to win a certain award. Some teams target winning an ILT, a regional. Well, in our case, we wanted to advance 2 worlds from SoCal. We knew there would be 3 slots, possibly an extra. There actually ended up being 4. So we knew to guarantee it, we would have to be one of the 2 Inspires or Winning Alliance captain to guarantee a spot. So we knew there was only 4 scenarios where we advanced to Worlds. So that was kind of very early on our analysis. So we started working really hard early in the season, actually at the end of the Frenzy season, getting ready to try to have as good of a season as we could the following year. We did a bunch of outreach because we knew we'd have to try to target Inspire. So we did a bunch of stuff. We did release some open source stuff. We did technical workshops, mentored 23 teams, reached out to a bunch of countries and had events in different places. And then we raised $31,000 for a charity. In terms of design, we finished our first robot up at the middle of September. And we used that for all of our league meets. Since leagues didn't really matter that much, we were just trying to figure out strategy while testing out different submodules on the robot. So we tested out our odometry, our path following, and then some other stuff. We redesigned in CAD to our second iteration, which we never built. That was done beginning of October, um, and we did not like it, so we just didn't manufacture it. It was way too complex. Um, and then we moved on to our third iteration, which is where we pioneered our turret design. There was some strategy that we saw we could stay away from the center line, which we saw early season would be a big advantage, so other teams couldn't interfere with our auto. And so then we kind of took a step back and we like refocused our robot. So like, okay, so what do we need to do? What are some of our actual engineering design decisions that we'd had to make? So we came up with four goals for our robot. So to stay away from center line, we have to score all six cones from um, the side stack in auto, and we can't tip over the robot from driver error. So mechanically, being unable to tip over the robot was a big thing for us, and we need to be able to score all the cones during teleop. And so then we came up with six or eight different points that were kind of key design decisions that kind of met those goals we came up with, and that helped us when we were going through our CAD. And we were really, really focusing on, okay, what can we do in each area of the robot to make it better? And that allowed us to design our fourth iteration robot, which is very simple. It was just a turret slides with an arm. Um, we were able to win SoCal with that. It worked pretty well. We had a 6 cycle auto. It was pretty reliable. Had no real issues mechanically. The only thing was there's just some flop in the arm that caused some issues, but we did had that so that we couldn't get hit and break an arm, which had been an issue we figured out earlier in the season. And then we rebuilt for Worlds. So after winning SoCal, we rebuilt our robot, made our vertical system a bit lighter, while switching to a pass-through design. So weren't just scoring off the side of the robot. We're scoring out the back of the robot because we figured out we could do teleop faster that way, but our auto could still remain away from the center line with the turret, which was a big advantage for us. Going into Worlds, we kind of set up some different keys, basically, and we were just trying to look at and see everything going in. What can we possibly do to give us an edge? We were able to look at a lot of the teams within Edison Division. We knew what everybody had going in, and we were able to build strategies up the week before, kind of play different scenarios out in practice to make sure everything was all ready. Going through our qualification matches, we went 8-3. We only dropped 3 matches. We lost to Terabats. We had a partner who was ranked really low, and then we lost to VC Silver Circuits, who ended up being the first place captain, and Auto Vortex, who was picked by the third place alliance as the first pick, and then our partner was ranked 48, and then we lost to 2 other teams, and our partner was ranked 43. However, we had some software discrepancies that caused issues on our robot during that match. We do a lot of tracking, so this was our tracking for all of our matches, and we could just kind of see projected scores versus actual scores, and we like seeing over projections, especially here on day 3. Our scouting was our biggest strong point as a team, so we scouted out quality control. We really liked their consistent auto. It was the best in the division. It was basically didn't fail at all. And we had them at our hotel for 2 nights of practice and just getting stuff better. So we knew we worked well with them. And then Don't Blink, they were the sleeper pick. We had seen some stuff mechanically in the robot that we really liked that could disrupt other teams' robots. And they overperformed their projections on average, which is a good thing. And then we saw that their opponents actually scored below their projected by a decent amount on average, which was a big thing that I think a lot of teams overlook is actual projected versus real life performance. So then we strategied the night before. We had a conference room we just did a bunch of practice in, and then we ran matches against Cruise Control, Kooky Bots, and Juice. And we're just able to get a lot of good practice in the night before, figuring out different strategies, and building up what would eventually win Worlds for us. We were able to win Edison in 5 matches. We dropped our semifinal 2 match. That is when Quality Control and Brainstormers both broke. So it was basically 1v1. However, we got defended a lot more, and that ended up being the swing of the match. We only lost by 5 points. Then going into grand finals, we knew it was going to be close. We weren't feeling great about it because we knew that the Wolfpack and Robo Octopi alliance would be really, really strong. So we were able to win the first match by 6 points, and which at that point we substituted in Don't Blink and Quality Control because we liked those matchups better. Because we paid attention more to the robot to robot matchups rather than um, overall just our alliance pairings, since we had a alliance that anybody could go with, play with anybody, and we'd do well. So we liked that pairing better. Um, so we had 4 keys we kind of saw um, afterwards that we kind of looked back. So Don't Blink's auto was a big thing. We helped them get stuff working on it the night before when they're having some issues, and we switched some stuff up there. So that was a big thing. Um, Ours, as well as quality controls, the autos were really good. Quality controls was a safe auto, couldn't be disrupted. Ours was a defensive auto that would move the pole around a lot. We had our mirroring strategy, which ended up being really, really good because we could force robots to make decisions that weren't great. And consistency is key. This is the biggest thing that teams overlook. You design a robot that's too complicated or does too much. If you break it all or do anything that allows you to not score, it's not good. You have to be able to show up every single match and be as consistent as possible. The biggest issue we had all week was actually on day one on our first match, where I knocked over a stack of tower of cones, and that almost lost us the match there. And if we would have lost that, we wouldn't have won Worlds. So thank you for listening. If you want to contact us, our team's kind of defunct because basically everybody graduated. Um, there's only, I think, 2 members left that haven't graduated yet. And so yeah, there's our email and our Instagram if you want to reach out there. Um, I'm also on Discord. Just if you type in Gator or Joseph Gator Bytes on the FTC Discord, I'm there. If you have any questions, you can DM me there sometime, and I'm on there sometimes. I'm just busy with school. All right, thank you.
Thank you, Joseph and Gatorbytes. We appreciate that you joined us and helped us today. And we understand that you already graduated, so you actually didn't need to help us. So we would like to thank you for that. I'd also like to emphasize to you guys that Joseph and Gatorbytes, they were the world champion in the power play season. So out of like the thousands of teams that season, they were the winner of that season. So I'd like to congratulate Joseph. I'd like to congratulate you for that achievement. And we actually met Joseph and Gatorbytes during the league meets, and we learned a lot from him. So we would like to thank him for all the help he's given us. Thank you, Joseph.
No problem. You guys are awesome.
Thanks. Next up is Java the Huts. Whenever you guys are ready.
Yeah, 1 second.
Yeah, no problem.
Hello, can you hear me?
Yeah, we can hear you fine.
All right. So I'm Dira Sharma from Java the Huts. I have 2 other team members from our team here with me. We won the World Championship in the Freight Frenzy season along with Delta Force and Upper Creek. We advanced to the Worlds through Inspire that season and again last season through Inspire as well. I will talk quickly about the robot and then we'll let Natalie and Delaney talk about outreach, which we focus on a lot. So can I share my screen?
Yeah, do you have access? You're good?
Yeah.
Mhm.
When we're building a robot, the steps we take are we first CAD our entire robot in Fusion 360, and then we have access to a laser cutter. So we first make a wood version of our robot, so a full wood chassis, and then we our final chassis material is carbon fiber. So this year we have a full carbon fiber chassis and extension that's on a pivot for intaking and scoring. Carbon fiber slide inserts where we thread directly into the carbon fiber. Our intake has a wrist and tilt axis. We use surgical sutures for stringing, and we have a flip down bumper system that helps us align with the wall. So all of our features have been we study like other robots from like FRC and other FTC teams and stuff from the past as well. And we take features from previous seasons as well. So like our carbon fiber slide inserts we took from last season. We made this innovation in center stage, and then our intake wrist until axis. We took that system from last year, and the same with the string, and then we added all of the other innovations this year. So now Delaney and Natalie can talk more about outreach.
Okay, so one of the main ways that we like to do outreach is we inspire through camps and mentorship. So we do a lot of camps like Robo Rumble where it's about 2 months and it's every weekend and we just teach kids like basic things that you would learn in, for example, FLL. So we have them build with robots. I mean, build with Legos, I'm sorry. And then we have them code their robots and everything. And it just gets them started up in STEM and gets them really influenced to start other STEM activities. And then we also volunteer and mentor other FLL teams because most of our team comes from previous FLL teams that were very successful, so we know a lot about it. So we really like helping the FLL teams and tell them like we listen to their presentations and things, and we'll just say, okay, well that's great. Here's how you can do it, and that'll also inspire them like, okay, well I know you might have been struggling before, but you can do it. So they'll stay with they'll stay with it and they'll start moving on. Okay, can you go on to the next slide?
Dear, you need to transition to the next slide.
Um, and then we network at large STEM events. So we'll go to like places where there's going to be like a lot of people, a lot of kids. Well, preferably places that is already STEM invoking, so that we know that the kids already like STEM. But if not, we can just get them in. So we'll like to show like here's what it can involve in, like here's what even like a little interest might evolve into. Here's what you can become doing with FIRST and STEM. And then it's one main thing is a lot of teams just focus on like, okay, how many kids can we reach? But you also want to like have a follow through. So we'll have like little sheets and it'll show like, okay, what is your name? Where are you located? What school does your kid go to? And then we'll reach out to them a little later after we look up everything and we can say, okay, well, here are some FIRST programs at your school, or if they don't have any, here's some in your community. And I think that that really helps like them follow through so that we'll do all the research for them and then they just have to sign up and it really gets them involved.
So a huge part of our outreach strategy has to do with impact over amount of people attending. So initiating industry connections is one of the most important part of what we do. So that would be the non-technical out or the technical outreach as opposed to our non-technical outreaches. So one example of this is we visited the Gulf Coast Medical, visited the Gulf Coast Medical Center's robotic surgery unit. So we basically toured their entire robotic surgery wing and got to even use some of the equipment and operate that. We did it in partnership with another organization called HOSA. And so that was a really wonderful way to sort of learn about a STEM career, as FIRST is such a huge pipeline. Making those connections is very vitally important. It's also a great way to gain sponsors. Additionally, we visited the sheriff's office in our area and we learned about their robot, how they use robotics. So like the dogs that they use as like sort of police officers in of themselves. We learned about their surveillance systems. We got to tour it. Really great way to sort of connect with people in our area who are already doing things related to STEM and sort of show them how important STEM programs like FIRST are. There was additionally Tomlinson Aviation and Paragon Flight School. So we learned a lot about aerodynamics and explored how robotics is used in that. We got to tour AdMan, which is it's a 3D printing laser cut. It just like all sorts of manufacturing facilities. We visited Bob Dean Manufacturing in partnership. We invited a team that we were mentoring. We like to do that quite a bit throughout our outreaches, is invite other teams in our area, as they might not have the same opportunities that we do, since they haven't been around as long, they don't have the same connections, etc. So these sorts of events are very, very vital to what we do in outreach. Dira, can you transition to the next slide? All right, so another big part of what we do is advocacy. We do advocacy on a local, on a state, and on a national level. So we participated in the National Advocacy Conference at Washington, D.C., and we met lawmakers there to advocate for increased funding for STEM programs. Like FIRST, that was huge. That was an amazing opportunity. We did something similar on the Tallahassee National STEM Day, where we traveled to Tallahassee, we visited the state capitol, and we met with legislators there to gain support for the funding request LFIR 1752, and that was a bill advocating for increased funding for STEM education programs. And that sort of our presence there was extremely important, as we are and teams just like us are living proof of how important STEM education programs are and their true benefits. So it was really huge that we were there. Like I said, we do advocacy on a local level as well. So we've done extensive local advocacy, ranging from the superintendent at our school district. We met with him directly. We presented our robot, we presented our outreach, essentially just our team and our program. And we spoke with him about our plans and our need for support in starting new teams in the area. Our area is very, very lacking in FIRST teams. We only have one public school FRC team. We have no public school FTC teams. We personally are a community team. And I think we only have about 3 public school FLL teams. So we're trying to change that. That's a huge part of what we're doing. As like I said, FIRST is such a big pipeline. We go to schools directly there, and we bring our robot, we present it to them, we show them the true effects that FIRST brings to students, the skills that it can teach. We went to our local student school board and presented that to them, gave a direct call to action, asking for them to start new teams if they could, like, essentially just support what we're doing. So yeah, the reason why this is so vital to what we do is it's about the biggest impact possible, is increasing STEM funding, increasing STEM opportunities for other kids. So that's really our main goal. I think that might be the last slide.
Yeah, that's the last slide.
All right. Thank you, Java the Huts, for your presentation. You guys seem really strong in your outreaches. So I have questions to ask, but I'll ask them after everyone's done presenting. So the next team that's presenting is technical difficulties, if you guys are here.
Yes, let me share my screen.
Right.
Okay, sorry. Hi, we're Team 7172 Technical Difficulties. I'm Shreya, and I'm presenting here with Hebe as well.
Yeah, I'm Hebe. I'm a programmer on the team.
So a little bit about us. We are a 12-year community team in the Dallas, Texas area, and we're going to be presenting about our Power Play season. So our Power Play season robot was called Phoenix, and I think one of the key points about it was it had a total of 13 feet of extension, and we used a multitude of sensors. And some of the key points about hardware, we had 2 identical arms, and we had a industrial CNC gearbox running the first pivot, and we had a few sensors that Hibi's going to talk about.
Yeah, so our team's whole philosophy over programming is to program as much automation as possible to make driver control period and also autonomous as effective as possible. And to do that, we have a lot of sensors implemented. And then on Phoenix specifically, that was our first year using the HuskyLens sensor, which is a sensor we found and requested to be added into FTC. And we wrote a driver for it, and it is now official in the FTC library, but at the time it was a customized driver. And the point of HuskyLens is just it's onboard computing, so we don't have to compute anything on the actual control hub. And all we need to do is to call to request for the data, and it can do several different tasks, including object detection, April tag detection, and also color detection. We use this to center ourselves onto the poles to effectively score on top of our presets that moves the arms. And since we have two arms that we need to control, we used a coordinate system that we customized using potentiometers to know the degree of the arm that we're at, and also presets that we record through a calibration program that we can run every time we reset the robot.
So as well as our hardware and software, we also focused on outreach in the Power Play season, and we reached over 20 FLL and FTC teams through our work in assisting and mentoring them. And we also had a few key opportunities with companies such as SpaceX. We got to visit and present at their facility, and we hosted many scrimmages in our region as well. And we also presented at local elementary schools and tried to spread FIRST as much as possible in our community. Okay, so for the North Texas Regional Championship, just a little bit about our experiences. We actually started out with another robot design, and the North Texas Regional Championship was a chance for us to try out this new two-arm design, and it ended up working well for us, although we had some problems with defense, and this led us to implement more strategies as to how we could combat that by driving around more on the field rather than staying in one place and scoring our cones. Hibi.
Okay, during the Texas State Championship, we actually experienced a pretty major issue with our arm since we have two sides of the robot. Our robot's symmetrical, so it's built so we have a split drivetrain. We have a control hub on one side and expansion hub on the other, and then one arm on each side of the hub. And during Texas Championship, during the qualification matches, one our arm actually broke down. And this is when the implementations we actually did for the North Regional Championship actually came into play. Because after that, to counter defense, we actually had a lane mode, which means that instead of using two arms and sitting in one place, we actually close the robot together and then actually just drive through one lane and only focus on one side of the field. Because we broke one of our arm, we were only able to use one of them, and lane mode was actually used so we can still score despite our robot being half broken, literally. And stop. Wait, go on. Wait, Shreya, you can go.
Okay. Yes, and then we got to the World Championship, and our experiences in the past dealing with defense as well as improving our autonomous greatly helped us. But one key issue that we had at the World Championship was the lighting, as there were very bright stage lights on in all the matches, and this affected our HuskyLens performance. And I think Hebe can go into more detail about that.
Yeah, since we use the HuskyLens to basically during that season, we replaced the webcam with HuskyLens. So we use the HuskyLens to detect the April tags for the actual automate randomization of the autonomous period, but because of the lighting, we weren't able to see the QR codes consistently, so we missed several randomizations. After that, we kind of learned from our lesson, and this year we implemented LED lights that shines only when the Husky Lens is running to make sure the Husky Lens can see everything in front of it, no matter what lighting it is. So it's a consistent lighting. Also, we tested the range of different sensors, so we found out that Husky Lens has a lot shorter range from the webcams, and so we need to use it in the correct scenarios when we need a faster response time instead of the longer range but better vision. So webcam is still a better choice for in any APROTAC detections, while Husky Lens is useful when you're trying to do micro adjustments on the robot.
So overall, through our season of iterating multiple times through starting with a different robot and eventually reaching our two-armed robot design, we were able to win the Innovate Award. And yeah, this was a great conclusion to our season and a testament to the unique nature of our robot. Thank you.
Thank you, Technical Difficulties, for your presentation. I found the world slideshow really interesting. So next up, we have Curiosity. Whenever you guys are ready.
Hello.
Hello.
Hi everyone. We're Team Curiosity 11770 from Los Angeles, and we won the Think Award at the World Championships last year. We are so excited to be presenting here today, and we're excited to tell you more about our journey to the Think Award in the Ochoa division. So here's a quick overview of our season and our team. We are an all-girls team founded in 2016. Last season, we welcomed 12 new team members after having a lot of our members graduate the year before. We won the Connect Award at our first qualification, and then we qualified to regionals from that. And then between our qualification and regionals, we almost fully rebuilt our entire robot. That decision really paid off because we were able to win the Inspire Award at Southern California Regionals, and that allowed us to advance to Worlds. There, our portfolio allowed us to receive the Think Award in the Ochoa division, and our portfolio is something that involves the entire team, and we modify it between each meet to make sure it's up to date and that it's really showcasing our entire team. We make sure to highlight our unique team structure, our long-standing outreach and its impact, our robot, and then the principles behind the robot's build.
Hi, I'm Riley, and I'll be talking about our design process. So basically, our designing our robot is like ongoing, but we start immediately following season kickoff in September. The first part is we research the game in depth and we name our functional requirements, which are like the goals or intentions for our robot. And then this is a process that the whole team is involved in. We start by sketching a bunch of different concepts and then giving each other feedback on those designs. And then based on that, we decide like one or two mechanisms for each subsystem or game task. And then we start CADing in Onshape. And we use Onshape because it's sort of like the Google Docs of CAD. We can all work on the same document at the same time. And then after we have our full robot CADed, we start, and we like prototyped and tested, we start fabricating. And then we continue iterating throughout the season, and that process is never truly over for us.
So this is a little bit more on our robot from last season. This is the Onshape screenshot, but as Riley said, we use the CAD program Onshape to fully build our robot. We then moved to fabrication at the end of our season last year. Most of our robot was built out of CNC'd aluminum and polycarbonate, which you can see in the image. And every season we pick a few core design principles that help us build a robot, and we keep them in mind while building our robot. So last year that was automation, modularity, and compactness. And that really helps us kind of shape our design in every design choice we made.
Okay, so our team connects with multiple STEM professionals from around the world. So we typically reach out in a variety of ways, such as personal connections, like parents, friends, etc. We connect via Instagram or even finding profiles on LinkedIn and just cold emailing. We don't always get a response, but people who have responded are extremely kind and willing to give us advice about careers after FIRST and applications of robotics in real life. We've been able to connect with companies like NASA, Northrop Grumman, JPL, Aerospace, and Nation Builder, and we highlight this in our judging presentation, specifically how we've learned and grown from our advice, or from the advice, which is how we were lucky to get the Connect Award at our qualification tournament. Additionally, we have a strong network of alumni from our team who are always willing to give us advice on how to solve problems with the robot or giving us feedback on our judging presentation. and we've been so lucky to have our former team members come back and provide us with their wisdom. We've also connected with FTC teams from around the world, including Australia, Brazil, Turkey, Greece, and Kazakhstan. And fostering these relationships allowed us to gain invaluable advice from other teams, and as well as being able to offer advice of our own to these other teams.
Our team loves to engage with our local community in a variety of ways. Two important components of our outreach are longevity and impact. Some ways we've managed to showcase these are by starting and funding an FLL team at a local community center where we visit weekly to coach them on how to build, code, and create a robot, and how to be well suited to compete in a real FLL competition. We funded this FLL team through our team bonding bake sales, which allow us to purchase the FLL fields as well as the robot kits and registration. Additionally, we've taught lessons for the past 3 years at Mar Vista Family Center, which is where we teach STEM classes to underprivileged students in grades K through 6. Our team finds it really important to be able to spread the message of FIRST throughout our community, while also giving people an opportunity to be able to grow and explore in the world of STEM. We also teach and present FIRST at a ton of local community centers and elementary schools as a continuation of our mission to spread the core messages of FIRST in our community. This was all based on our core outreach goal of expanding access to STEM in underserved communities, which guided us through all of our outreach efforts throughout the season.
Okay, so our season wasn't always smooth sailing. At our first official robotics competition, we had several hardware issues that led us to ranking really poorly early on in the robot game, which was a really big disappointment and a pretty big setback for us, but it gave us a bigger motivation to work harder and improve. After that meet, we were working even longer hours, iterating and fixing our subsystems, and we put hours upon hours of dedication to create a better and more efficient robot, and it paid off. And the work we did allowed us to go up 10 spots at the next meet, which really allowed us to grow and learn as a team, and is a big aspect on how we got to where we are today. And for all the problems we faced, we are so happy that we were able to overcome from them, and we learned that it's never late to improve, and going from last place to a first place Inspire finish at regionals demonstrates our growth and journey as a team.
As for our portfolio, this is actually a really big part of our team's work. The main things is starting early so that you can give yourself enough time to really put in the time and effort to make your portfolio as good as it can be, and also maximizing the space that they give you. We use all 15 pages, and we split that work up evenly by assigning each team member to one page. Basically, we try to make it as easy to read and engaging as possible for the judges by using a lot of pictures and diagrams so that they can understand our robot through a more like visual sense instead of having to read blocks and blocks of text. Of course, we do have text as well that contains like a lot of the information that we want to like convey to them, but we really make sure to have every word and sentence that we put into our portfolio count so that we don't have any like extraneous information that's taking up space that could be used efficiently.
Okay, so one tip we have for the portfolio is to document and keep everything possible. So we assign one person to take photos at every competition, at every outreach event, etc. And we have a shared folder with all of these that we use for social media and the portfolio, and we have it separated by season and event. We also ask some professionals and during Zoom calls if we can take a screenshot with them that we also put in our portfolio. We also keep every sketch, old iterations, prototypes, and calculations. And an engineer notebook is not required anymore, but we still keep one so we can document the entire process and keep the design process organized. We also probably had several boxes filled with old iterations and paper sketches, and this made it a lot easier for us to have really detailed timelines in our portfolio.
We are so grateful to have been able to win the Think Award at Worlds last year and to have the opportunity to present at this forum. And we're really excited for the Into the Deep season. After having reflected on last year's robot game, we're hoping to get started a lot earlier on our iterative process so that we can have more time for programming and driver practice. And then we also want to start our outreach earlier in the season as well so that we can have more time in like the fall for working on hardware. And we're also hoping to incorporate new types of materials. After we went to Worlds, we saw a lot of teams using things like carbon fiber, which we've never used before. And so that's one of the main things that we want to improve on this year. And we are also excited to announce that this season we've been doing engineering portfolio reviews. So any team can send us their portfolio through our website and we'll give them feedback on how we would improve that. So if you or your team are interested, you can check the pin post at the top of our Instagram.
Thank you all so much for listening. All of our socials and like methods of communication are on the slide, so feel free to reach out if you have any questions whatsoever. And everything of our resources and portfolio feedback is on the website. So thank you guys so much.
Thank you, Curiosity, for your presentation. You guys have a really strong portfolio, and congratulations on Worlds. Next up, the next team up to present is Tech Tigers. Whenever you guys are ready.
Oh, it's fine, just leave it. Okay, hi guys, we're the Tech Tigers. We're a fourth year team from Sharon, Massachusetts. My name is Amelia. I'm Alyssa.
I'm Josh. And I'm Rishi.
Yeah, so last season for the Center Stage season, we won the
Ochoa Design.
Ochoa Division Design, sorry, Ochoa Division Design Award, and we also had the #1 autonomous OPR at Worlds. Our mission as a team is to have fun, build an amazing robot, and give back to our community along the way. What?
Hold on. Not letting us.
Just click on it. Okay, that's fine. So this is basically a overview of our design process. So we always start the season by doing a lot of game analysis and strategy. So analyzing what are our possible scoring opportunities, what our robot can and can't do, and what's the best way to go about playing the game. Afterwards, from this strategy, we're able to derive some overall robot requirements. So these are things that our robot as a whole needs to be able to do. So for example, last year, some of those things included not letting pixels get stuck inside the robot, or being able to like score mosaics or things like that. From there, we're able to break our robot down into subsystems. So last year we had our dropper subsystem, the intake, the drivetrain as a whole, and then some other software subsystems. And then similarly, we do requirements and specifications for each subsystem. So these are more specific details that our team members can then use to make our design. So like when we go about designing each subsystem, we know we have requirements to refer back to make sure everything is up to standard. Afterwards, it's just design, building, testing. So we use CAD extensively. We use Onshape as our CAD software because it lets us iterate on designs really quickly. And we also have a CNC machine and a 3D printer so that we can, after we design something, we can get a really quick prototype in. So we're always updating things in CAD and fabricating it to test it out. Finally, afterwards, after we use these things at competitions or scrimmages, we do like extensive analysis about the different issues we faced. So at scrimmages in the past, we noticed that like, we'll get into this a little later, but we noticed that our robot we weren't able to see exactly what our robot was doing at all times, and we're able to come up with like a fix for that afterwards. So that's how we actually came up with our driver dashboard, which Josh will talk about a little later.
So last year's robot had a pretty compact 15 by 13 by 12-inch base that allowed us to quickly move around the field. And that, with our fast intake, meant we could have a pretty quick cycle time. Our dropper was able to rotate along 3 axes and could drop pixels either 1 at a time or 2 at a time in either a horizontal or vertical orientation. And a huge part of our robot that we really wanted to emphasize was our modularity. In past seasons, we had a lot of trouble switching out different subsystems, such as the intake or the dropper quickly, especially at competition if something broke. So we wanted each element of our robot to be modular, meaning the whole dropper could be taken off with only a couple of screws and really quickly. Our entire robot design was also inspired by self-driving cars because we had a lot of sensor use and algorithms in our pathfinding system, which Rishi will get into later, that helped us achieve the overall functionalities of our robot.
All right, so as Amelia mentioned earlier, this was one of our key innovations this year, or last year, I would say, is our driver dashboard. So this is basically just an array. It was three different LED boards with one on each side and one mounted on the top of the robot that you can see here. It's controlled by an Adafruit driver, and each of the 384 LEDs that we had on our robot was able to be individually controlled. So what we would do is we would take in data from the robot, such as the data that the color sensors read when they were facing towards the dropper. And if you can see on the edge of the top board, we would actually light up the pixel colors as they would come in. So this would allow the drivers to see the information that, as Amelia said, we weren't able to see before. And we also have other things on here, like the intake height and a game timer. So the drivers don't have to look up and they can focus on the robot game. And this is our Pathfinder system. So this was really key to our autonomous last year, especially with the amount of obstacles that were on the board. And what it allowed us to do was avoid and recover from obstacles that we hit on the field during autonomous. So we would have a map where we would set basically this map over here that you can see on the left-hand side it tells the robot where it can drive and where it can't drive. So when our state machine noticed that our robot was knocked off of its path, it would create a new path, but it would only go where the robot was told it would allow to go. So it wouldn't drive into trusses or things like this. And this was an example of our Pathfinder at Worlds. So you can see that the robot crashed into the truss and it was able to correct itself and continue to score full autonomous.
All right. So in addition to our Pathfinder LEDs, what we pride ourselves on is creating a lot of autonomous and semi-autonomous functions to make the autos better, as well as making the teleop better. So on the left, that's actually another example of Pathfinder, but it's showing how the robot is adapted to collisions. We have conditions in there to make sure that the dropper doesn't get stuck. And there's a lot of autonomous capability built in to make sure that we have a resilient robot. And on the right-hand side, you see some of our semi-autonomous movements, which include our semi-autonomous intake, which would use some color sensors inside the robot to detect when we intake pixels and automatically stop the intake and bring it up. We had a lane assist, which allowed us to, when we were driving, we were able to latch on to one lane using odometry, and that would allow us to stay on a lane and not hit the truss while driving. And we would also automate our button presses to go out to drop positions. So that helps save time for the drivers. So to do all this, as I mentioned, we need a lot of sensors. We had 3 color sensors, 1 on the dropper and 2 inside the robot. The one on the dropper was to detect the backdrop, so that we could detect and move close enough to the backdrop so we can drop it. And the 2 inside the robot, as previously mentioned, was to detect when pixels were in the robot and what color they were for the LEDs. We had 2 distance sensors in front, which allowed us to have accurate stack intakes. We had a camera so that we could detect Able tags on the backdrop and relocalize ourselves based on that, accounting for dead wheel odometry drift. We had an external IMU because we thought it was more accurate than the one on the controller based on our testing. We used the motor encoders for accurate slide positioning. Dijkstra's algorithm was used for Pathfinder, and we used that in our Pathfinder system with the waypoint-based trajectory generation to create our paths.
Okay, so that's the end of our presentation. Thank you so much for listening. If you have any questions, you can reach out to us at our email. And you can also check out our website, which has all of basically the majority of the work we've done in the past few years has been published on our website, so you can use it for anything, and also
also we have released a quick start with a lot of resources that we have used in the past, and that's a code quick start. So it's on GitHub, which you can also find through the website, and it has access to things you coded like the LEDs that we mentioned and Pathfinder. So both of those are there. There's also some other stuff that we think is pretty cool.
So check it out if you're interested.
Thank you, Tech Tigers, for your presentation. I'm extremely impressed with your robot's design So I'm not surprised you guys got the design award. And also, I'm not surprised if you guys got the Connect award as well. It's a really good robot. And the last team to present is Atlas Tech Titans, if you guys are here. Nope. All right. Well, if you guys have any questions, you guys can, this is the time to ask them right now. You can type it in the chat or just unmute and ask any of the teams the questions you guys have saved, hopefully.
Hello?
Hello. Yep, we can hear you.
Yay. Okay. So, this is for any team really, and this just has to do with outreach. So for our team, even though we've been in the game since like 2012, I believe, our outreach has been really weak. Like, I think since Power Play and Center Stage, we've started to actually get our game going. But like we are still kind of like have the resources of a rookie team, you know? Um, hold on, let me try. My main question, and can be for any team, how can a team succeed in outreach despite like limiting circumstances? Like if their advisors tell the team like, hey, like we're really like we don't have time to, do stuff outside of, regular team meetings and stuff. And if you need me to clarify anything, then, ask.
So if possible, I'd like to take this question. So a big thing that our team does specifically that I heard another team mention about is using your first level contacts. So even if you do have limited resources, turn to the members on your team, turn to their parents, see what connections you already have existing. So a lot of our sponsors come from these first level contacts. A lot of our outreach opportunities come from these first level contacts. This applies to both technical and non-technical. So for instance, our title sponsor is Arthrex, which is a medical engineering company in our area, and they are huge. They are I think one of the largest biomedical engineering firms in the world, or in the nation, my bad. So we had a team member whose father worked very closely. I'm pretty sure he was a part of the company, and he was simply talking to his coworkers about his son's achievements and his son's team, and they took great interest in this in our program, and they asked, they wanted to know more about it. We ended up scheduling a tour of their facility and, most importantly, a presentation of our robot and our program. And from there, they were so interested in what we do and they were so inspired by what we do that not only did we receive a sponsorship from them, but we also managed to start a team based out of the his coworkers' sons started their own team. So, even just like your parents might have a connection that can develop into a sponsorship, into another team, into an outreach opportunity. We did the same with non-technical outreaches. This is actually a technical outreach example, but Bob Dean Supply, we knew from a family friend. We simply asked to tour their facility, present our robot. We sent a follow-up email saying how much we enjoyed touring their facility, learning about what they do, and we hope they feel the same about learning what we do. We sent them a few pictures from our outreach, and then we, from there, presented our sponsorship opportunities, what they receive as being our sponsor, how it benefits them, and basically offered the extension of our partnership. So that's a really great way to sort of, not just establish a connection, but really create something out of that connection. So really my biggest piece of advice is look at those first level contacts, utilize those first level contacts, and send out an email. Be confident about it. Yeah.
Oh, that's really sweet. Thank you.
And then in the chat, Sarah S had a question. She asks, this is a more general question for any team willing to answer, but how do teams allocate time between hardware and software to ensure code team has enough time to work on auto? Anyone wants to answer that?
I can jump in on that one because that's something that we dealt with a lot, especially in the Freight Frenzy season. Our code had to be integrated with our hardware at like a really, really tight level. So you don't want your modules sitting. You want your hardware module here, you have your software module here, the kind of teams working independently. We had a lot of not only cross participation, but also cross work through the CAD process and the software process to get development pushed forward, not just on a base level for each, but kind of almost together so that you have better communication between different parts. A really, really well-designed robot with bad code is not good, and a really, really well-coded robot with bad design is also not very good. You have to have at least a decent level of each to have something that will perform really well at a high level. So one thing we would always do is we have what we call hardware deadlines. So a month before each competition is hardware deadline change, except for like emergency cases where something breaks or is consistently breaking. But no major design changes are made to robots within a month of competition. And that allows 2 weeks to develop out all the code. And then another extra week and a half for auto tuning and any fine tuning that needs to happen on different systems, as well as 2 weeks of driver practice. Because your drivers have to be very familiar with the robot, as well as having a member on the drive team from the hardware team, from the software team, and the engineering team. And that just helps overall. Any issues you can diagnose in match a lot quicker, as well as just having drivers who completely understand the inside and outs of the robot and are able to not just drive the robot to its limits, but not overdrive the robot. Because a lot of robots have turn rates and stuff that are your theoretical maximums. So it's better to have a driver who can drive to the robot's limit and not overdrive, because then you'll start scrubbing stuff, losing power from batteries, and just overall you'll get better performance from having integration from all the different sub teams. But yeah, 1 month hardware deadline is a really good way that we used to just make sure stuff gets done.
Another question I was asked by Mila. And I think this might be for a specific team, but they didn't mention it.
I think it's for
sorry,
Catherine. I think it's for Gator Bites. I remember I saw the question pop up after his presentation. Yeah, Catherine, you can continue. Sorry.
The question is, do you guys have autonomous that adjusts to what is going on in the field, or does it just do whatever it does?
So Eileen, at least for our team, we had an autonomous that we had a few exit states that if we got too far off of our positional lock or we got pushed, we'd just try to park. But for the most part, if we were within the general area, it was better for us to keep trying to score. At the very worst case, if we're not grabbing cones, it's moving the pole and going to prevent other teams from scoring in the worst case. And I think it did try to do an exit case, and I think was it match 58, I want to say. It was our match against VC Silver Circuits and Auto Vortex. Our pole guide got tangled with VC Silver Circuits, pole guide, and claw, and we basically were like locked together until it got unlocked at the very end when it was just trying to go park, because then VC Silver Circuits tried to go park. So it was trying to exit for a while, but stuff was not working, and that was a very exciting match to hear your robot making very loud sounds while it's not scoring. So yeah, we have a few X cases, but not as many as a lot of other teams had.
I would like to add that for our team specifically, we have 4 different like main programs. So like for red side right, red side left, etc. But at the end, we have a lot of different states that we're able to do. So like, for example, like either park here or like park somewhere else. And that just allows us to be compatible with so many different teams. And we're able to talk strategy to ensure that we don't collide with each other during our autonomous game.
Hi, so I have a question about judging. How do, and any team can answer this, how do you present all of this information when you're in the judging for only 5 minutes? Our team really struggled with that last year, and we're not quite sure how to do that. Any suggestions would be great. Thank you.
I guess I can speak from our team's experience. So, we try to limit like 2 minutes for hardware, 2 minutes for outreach, and then 1 minute for programming and our speech. But anything that doesn't get mentioned there, we try to incorporate these new ideas during the question and answer section. So here you can actually introduce like new information that you may have missed or any other important information that you want to add, and that helps create a more cohesive presentation towards your judges.
Adding on that, something that's really important for our team is practice. So, well, at the beginning, we usually have, in the past, we had each team member write their own part of the judging script. And we also think it's really important for every team member to have a part in the judging script so that you're sort of coming off as like a cohesive team and not as just there's only like one or two people who know what's going on. And so having one person write the whole thing and then split it up for your team is better because then the writing is in like a consistent voice and tone, and you're making sure you're not repeating yourself in any way. And then what we do is, or I'm the captain of my team, and then me and my co-captain will write the script, then we'll read it for ourselves, make sure it's under 5 minutes, cut it up, distribute it to the team members. And then we try to do that like as early as we can while still being close enough that the information in there is up to date when competition time comes. And so basically we try to only include the most important things and the things that are sort of going to get the judges to ask you questions in the Q&A, but then also in the pit. And so we also practice Q&A a lot. Whenever we give like our judging presentation, we write down the questions that the judges ask us so that we can use them for practice next year. And then we also give our presentation to a panel of like past team members or like other people so that they can give us feedback. And then we also ask like we are a school team, whenever we see our teammates in the hallways, we'll ask them judging questions like on the spot to make sure that they can come up with it like an answer like at any time. And it's also good to have multiple people answer the questions in the Q&A. I mean, if it's like a technical question and there is just one specific answer, but if it's something more open-ended, like what's like something you learned this year, you can have multiple different people sort of step forward and give a different answer so that the judges can get like a mix of perspectives.
To add on, Tech Tigers also said we like to reference the rubric and make sure we're hitting some of the key points that are being addressed in the rubric criteria. As for the presentation itself, we like to use a monitor because it's a good way to display visuals, animations, videos, etc. during the presentation.
Does anyone have any more questions?
So I had a few directed at specific teams. My first one is for Gator Bites in particular. So I would just like it if you guys could describe your scouting process a little bit more in depth. I found that really interesting and like just something really cool that you did. So if you could elaborate more on that.
The question of the year. So our scouting process was like really like top to bottom, and we actually spent more time looking for things that are like a lot lower level than like most teams. Like, oh well, who had the least dropped cones as for power player? This last year was like, well, who had the most mosaics or who had the most consistent auto. Often those statistics are taken outside of the context of a match. So we were able to use our scouting team back in California that we had watching matches, and they were able to just kind of take notes on different things and different things that caused outliers to happen. Because more often than not, you'll see outliers in over the 11 match schedule that it was. So you'd see a few outliers from teams, and it's like, well, oh, they're not very consistent, or this happened. It's like, well, within the context of what happened, whether or not something broke or another robot broke them, or there was a huge penalty that doesn't show up necessarily within the statistics, or they caused a huge penalty. There's things that can happen outside of just what the pure numbers say. So it's having that human element, being able to watch and say, well, that works well, or that didn't work well, but they're still scoring well. So why is that? And what everything adds to. And then on the other part of that, we looked up at matchups. Since we kind of we knew that VC Silver Circuits was going to pick Brainstormers. That was like a given, and that we knew that Overcharge and Terabats were going to Alliance partner. We were kind of able to build out a projected Alliance selection list of how teams would fall. And so we kind of knew who we'd have available to us as picks. So we had us fourth captain. We had a list of you have to have a minimum of 8 picks possible. It just do for every place higher. So if you were like third captain, it'd be less. It's changing this year at the regional level with 2-team alliances. But for 3-team alliances, it was a little bit different for us. So yeah, we just had that, and so we saw that Don't Blink's arm, it would rise up from the bottom as they were scoring, as their cone came over the top, and we really liked how that compared to VC Silver Circuit's over the top scoring mechanism, because we knew the power settings on Don't Blink's robot were going to be a bit more powerful than VC Silver Circuit's and probably overpower it. So that was a big thing that influenced that decision. The other thing is we were able to have some people who were there at Worlds with us find out that bigger details on teams' robots. So we found out that VC Silver Circuits didn't have odometry. So we were able to use defensive autos to target their robots specifically, since we knew they couldn't correct since they were just using drive encoders. So that's one of the big things that we did. It's very case by case basis. We went matchup. And so we like to see good matchups. We had designed our robot to beat Brainstormer's auto, since we knew there was a greater than zero chance, much greater than zero chance, that to win Worlds you'd have to probably beat them at some point in eliminations. And it just so happened that it was round 1 for us. So yeah, that's kind of how we do our scouting. It varies on team to team, but that's how we did it.
Right, thank you so much. My next question is for 7172. So, you guys mentioned briefly your outreach efforts. Can you give me some specific examples of the outreaches you engaged in? The images that you put on looked really interesting, so I just wanted to know a little bit more about them.
Yeah, sure. So let me go back to the presentation. So during the Power Play season, one of our biggest initiatives was reaching out through an organization called RDT to a hearing and visually impaired school. And we were able to present there and introduce robotics to them. And eventually, by the end of the season, we were able to fund a robotics kit for them. And that was a really rewarding experience for all of us. And yeah, some of the other pictures are also as part of RDT, which is an organization that works. It's called the Rural Development Trust, and it's in India. And we presented at a few of their events. And then, as I mentioned in the presentation, we presented at a few elementary schools. And we just presented about our robot and how to get involved in FIRST. And then we hosted a scrimmage with a few local teams in our area to prepare for the state championship. And then the last image, I think, over the summer, we got invited to the SpaceX facility, as they've been our mentors for a few seasons now. And we got the opportunity to tour their facility and present to their engineers.
That's really awesome. Thank you so much for sharing that. So my third and final question was for 11770. And you guys spoke a little bit about your global FTC connections. How did you guys establish those?
Yeah, I can touch on that a little bit. Our team's like one of our bigger things is keeping our social media and kind of our online presence up to date. So a lot of that is that we try and kind of post or like at least participate in opportunities that target teams kind of across the world. So some of those relationships, teams will reach out to us like via Instagram DM or something like that, and they'll ask us specific questions about our work and like if they want help and stuff. And then we also do a lot of Zoom calls. So we'll either reach out to teams that we want to learn something from, or we'll get team requests and we'll just meet with them on Zoom for like maybe an hour and kind of answer any questions they have and kind of talk about our seasons, our designs. It varies from like call to call, but pretty much just kind of reaching out and finding people online. And yeah.
We also met a lot of teams at Worlds, so a lot of people who are alliance partners are people that we just ended up befriending because of like matches, like people we went up against, or even just our general alliance partners. So we maintained a lot of those connections specifically from Worlds.
Thank you so much.
And there's a question in the chat from Maish. She said, as a mentor, I'm curious to know how you balance school/class responsibilities with FTC. The quality of your work is very high, so I'm impressed. I'm wondering how I can motivate my students to go beyond what I teach them to learn something I don't know. If any teams want to touch on that.
We can talk a little bit about how our team kind of does it. A lot of our team members are also engaged in either sports or schools and clubs and all that. So something we try and do is we have practice like 4 days a week after school. So instead of having the entire team come to practice all on the same day, we try and have like a few members come every day after school. So everyone can have time kind of to work on the robot or specific subsystem without like interfering with other people's work. And then also keeping in mind what tasks don't need you to physically all be together. So like really making sure that our online communication is organized, everything is kind of stored in the cloud so we can all kind of interact and like do the CAD at home. So then when we come into the shop the next day, we can actually just start fabricating right then and there. And we don't have to spend time CADing together in person because we can do that online. And then in terms of like motivation to like kind of learn new things, it's honestly a lot about observation. Like if we see a team that's really strong in like a specific thing and we don't know how they're doing it, we'll either reach out to them online or like look into like the odometry they're using and stuff like that. So just making sure that you're staying kind of competitive is also learning from other teams.
I'd like to add on to the first part of that question. How do you balance school and class responsibilities with FTC? One of the things that's really important to remember about FTC is this is just an extracurricular in high school. You will graduate from high school, and you will no longer be able to be a part of FTC. The things you learn in FTC can be really, really cool, but it's important to not compromise your future, compromise your grades, compromise college applications, just for the sake of having fun in First Tech Challenge. It was hard for our team because we had all of our members were in varsity sports, and a lot of them were also in varsity music as well as other programs. So we were like really, really busy. And as well as with college apps, it was quite hard. So a lot of times we'd only be able to meet like once or twice a week as a team. So it's like important to focus on other things. And I think it was really good that we all had outlets outside of robotics, so we didn't constantly overthink things. But it's really important to not let FTC become all encompassing because that's when you get students who'll burn out. And we had that happen to two of our members who were just working so hard leading up to Worlds that they burnt out and their grades dropped. Luckily, they were able to bring them back up before graduation, but it was kind of a thing we had to, as a team captain, as well as our coaches, had to kind of step in and say, "Hey, you need to go focus on other stuff right now. There's bigger things. There's always a bigger fish, and it's important to keep your life outside of first going well and not losing out on other important things in life."
I definitely agree with that statement heavily. A big part of what you mentioned was about how your team was largely seniors, correct?
Yeah, so we had I think we had like 4 senior team members and we had a few juniors who ended up just kind of basically making that their senior year. They're like, I don't want to do it next year. go out on top, kind of win worlds type thing. But it was, yeah, we were mostly juniors and seniors.
Yeah, I'd say that's a huge part of why it's so important to have a large age range, in part so that you can have I'm blanking on the term for it, but like cross like mentoring your younger team members, making sure that you'll have a legacy as a team. And it also helps to take some of the pressure off those seniors and juniors who may be worrying about college applications or other extracurriculars, the bigger fish out there, to, have more team members who aren't exactly as worried about those things, and who may not have as many responsibilities. I know our team in particular, we have some middle school members and we have some freshmen and sophomores as well. So that makes it really easy for us when, our older, more advanced team members might have, other things going on and might have other places where their attention needs to go. So that's one of the bigger pieces of advice I can give.
Yeah, that's a really good point. And I think it also does depend, like situation to situation. We were a school team, and our school is really small. We have like around 100 kids, so like 25 kids per class. So we just had some years where there was just like nobody wanted to join robotics. We kind of just had stagnated. And there's also other things. Like a lot of people are really into sports, really into music. So like some people would join and then quit because they just wanted to focus on doing other things. So it's like it does vary. So like if you're a school team, you might only be able to pull from 4 grades, or you might be able to, as a community team, pull from everybody. Or it's a lot of times figuring out your constraints. And that's like a real world thing. What are your constraints? And then working as a team to best accomplish the tasks while being limited by things that are out of your control.
Awesome. And then this might be the last question. Peyton asked, this is for any team. How do you make decisions, especially with disagreements between team members?
I can take this one. So for our team, if we have disagreements about how to approach something, we're usually pretty good about staying really objective about it. So it's not about who wants what, it's more about what makes the most sense and what's going to make the robot work the best, because that's or really anything else, like what's going to work the best for our team, because that's all of our goal at the end of the day. And then also, if you have the like capability to do it, I would say just like try out different ideas. So we have a pretty good number of people on our team. So if there's 2 ideas like specifically on the robot that we want to try out, we're able to pursue 2 different tracks at once and then like compare which one works better. So that's how I would say we go about it.
All right. Does anyone have any more questions? All right, we're like 30 minutes over time. So I'd like to wrap this up. I'd like to thank our 6 FTC champions for joining us today. Rev Amped Robotics, Gatorbytes, Java the Huts, Technical Difficulties, Curiosity, and Tech Tigers for helping us with this event, and everyone else for joining us today. I hope you all learned something from these champions and hope everyone has a great season. Thanks for joining our event.
Have a great time. See you later. See you soon. Maybe. We'll see.
Thank you.
Thank you, everyone.
Bye.
Thank you.
Thank you so
Hello.
much.